Have you ever pondered the peculiarities of quantum physics? Or perhaps you've heard of the famous thought experiment known as Schrödinger's cat and wondered what it's all about? Well, today we delve into these intriguing realms. Imagine a cat placed inside a box, along with a radioactive atom, a Geiger counter, and a vial of deadly poison. Now, the radioactive atom may or may not decay. If it decays, the Geiger counter detects it and breaks the vial, killing the cat. If it does not decay, the cat survives. This is the setup for Schrödinger's cat experiment. In our everyday logic, an object is either in one state or another. For instance, if you flip a coin, it's either heads or tails. It can't be both at once. But in the quantum world, it's a different story. Particles can exist in what is called a superposition of states. They can be in multiple states simultaneously. For the cat in the box, the radioactive atom is in a superposition of decayed and not decayed states. Consequently, the poison, the cat, and the entire system exist in a superposition as well. Until we peek inside the box, it's as if the cat is both alive and dead at the same time. Only when we open the box and observe the cat does its state become defined as either alive or dead. This quantum leap from superposition to a defined state upon observation defies our normal logic. This may sound strange and counter to our everyday experience, but it's a fundamental feature of quantum mechanics, and the mental experiment of Schrödinger's cat illustrates this point. Now, let's further simplify the concept of the observer in quantum physics. Imagine playing a game of hide and seek. Until you find your friend, they could be hiding anywhere in the park. It's as if there are multiple invisible versions of your friend hiding in every corner. But the moment you spot them behind a tree, they cease to be in all other places. By observing them, all other possibilities vanish, leaving only one reality. This is, in essence, how quantum physics works. Tiny particles like electrons or atoms can be in several states or places at once until you observe them. When you measure their position, they collapse into a single state. Your observation essentially dissipates the quantum magic. In our everyday life, things are either in one place or another. But at the atomic level, observing and measuring particles is what makes them behave like normal objects, devoid of their special quantum powers. This highlights the critical role of the observer in quantum science. This thought-provoking exploration of Schrödinger's cat experiment and the quantum world may leave you with more questions than answers. But that's the beauty of these concepts. They push the boundaries of our understanding and make us question the reality we perceive.